Hi, everybody. It's Miss Rose. In case you were curious how to do these honors problems, I am going to show you a couple methods of how you might do them. So for the first problem, what we did in class every time we had 3 points and we were working with collinearity was we labeled them A, B, and C. And then we found the slope from A to B, and then we found the slope from B to C. So that's what I'm going to do this time too. So slope from A to B, I'm going to do change in Y over change in X. So 35 minus negative 11 over 20 minus 4. 46 over 16. I think that simplifies because those are both even. So I think that would give you 23/8. Then let's look at the slope from B to C. So I'm going to go change in Y over change in X. 29 minus 35 over X minus 20. So that would give negative 6 over X minus 20. So what we learned in this unit is if 3 points are collinear, then the slope that you get between the first 2 points and the slope that you get between the second 2 points are equivalent to each other. So we want to, in some way, use that fact to figure out what X equals. I saw a bunch of creative ideas of what you could do here. I actually just went back to an old strategy I remembered from algebra, which was cross multiplying. So I did negative 6 times 8, which is negative 48. And that's always equal to what you get when you multiply the other two by each other. Multiplying 23 by X minus 20 requires the distributive property that you might remember from algebra class. So negative 48 equals 23 times X minus 23 times 20. That's 460. Let me just use my calculator and check. Yep. And then I can add 460 to both sides. Negative 48 plus 460 is 412. And I'm going to divide by 23. And you have 2 choices. This gives you a messy decimal. If you want to be exact, you could just say 412 over 23, which is a nice answer. If you want to give the decimal approximation instead, that looks like it's about 17.913. So either one of those would be good. If you did it a different way, check and see if you still ended up with the same X value as I did. There's lots of methods for how you could solve that one. Let's take a look at the next problem. What always trips people up on this is coming up with some good coordinates for these points. So a lot of times people think that that the coordinates should be 4, 4, but if you picture this being on an axis, you're actually going to want to go 0, 4. And then B is only over 4 and up 7. A lot of times people think it should be 7, 7. It's actually over 4 up 7. And then C, how far over do we go for C? We go over 11. And then up, these are squares. So if its dimension is n, then it's an n by n square. So 11, n. And all of a sudden, this reminds me a lot of the last problem that we just did. 0, 4, 4, 7, 11, n. A, B, and C. We want the slope of AB, we want the slope of BC, and then we want to set them equal to each other. So I'm going to find these slopes pretty quickly. Change in Y over change in X. Change in Y over change in X. And then I want to set those equal to each other. I'm going to use the same strategy that I used the last time with some cross multiplying. 3 times 7 is 21. And then I'm going to have to distribute for this one. 4 times n minus 7 is 4n minus 28. I canceled out the wrong ones. Okay, 49 equals 4n. I think this one comes out to be a decimal too, but it's not a messy decimal, so we can leave it as 49 fourths, or we can get 12.25. And then the second part is just asking for you to do a little bit of generalizing. It's saying, what if they weren't numbers? What if they were variable lengths instead? So instead of 4, it's saying, what if this was m? And instead of 7, what if this was k? Well, all of a sudden, our coordinates for a would be 0, comma m. Our coordinates for b would be over m up k. And then be really careful for this one. If you remember, where did we get the 11 from? We added 4 and 7. So this one would actually be m plus k, comma n. So we have 0m, we have m k, and then we have m plus k, comma n. And it's basically saying solve for k, but you're not going to get a number answer this time. So let's do the same thing again. A, B, C, slope of AB, slope of BC, and then set them equal to each other. So the change in y is k minus m. The change in x is actually m minus 0. So that ends up being k minus m over m. Be careful because those m's don't actually cancel. They kind of look like they would. And then the change in y values from b to c is n minus k. And the change in x values is m plus k minus m. We have an m minus m. So we have n minus k over k. Same thing, those k's don't cancel. And then we want to set those equal to each other, and then it says to solve for k. So what do we get when we cross multiply? M times n minus k, k times k minus m. So let's see what happens. mn minus mk. K times k is actually k squared. Minus, I could write this as km. I'm actually going to write it as mk because I noticed that there's an mk on the other side of the equation. And if I add mk to both sides, those are going to cancel. So I have k squared equals m times n. So how do I solve for k? If it's k squared, I can actually square root both sides. So k is the square root of m times n. Interesting. Let me know if you have any questions, and I'll be posting more honors problems next week. Bye.